Okay, well, our keynote speaker for today is Doug Junkins, the CTO of NTT America. And I actually invited Doug to be, he was one of the very first invitations I made for this event when we were going to do it, because I've been talking to Doug for, I think, 2 years now, or at least a year and a half, about the whole IPv6 transition. NTT was early to the game, not only in getting its own network ready, but in becoming something of proselytizing a little bit for the need to make the transition among enterprises, but also among other service providers. And I know Doug has been a very strong voice in this arena, so I thought he'd be an excellent keynote. So I'm going to hand it right over to Doug.
Oops. Now my note cards are out of order.
Oh, sorry.
That's okay. I can probably wing this just out of memory, but it's something I've been talking about for a long time. So Carol asked me to come up and talk a little bit about, originally it was going to be talking about what people need to be doing now for IPv6, what the transition mechanisms are and things like that. But there are so many good panels at this conference covering those topics in more detail than I ever could that I wanted to take a step back and see if I can find my presentation here now. Is there someone that, okay, there we go. So instead of talking about all the different transition mechanisms and everything, I decided to take a step back and look at not why now, but why IPv6. I think everyone here is here because they realize that IPv6 is important, but sometimes it's good to take a step back and look at exactly why it is that we're going through this big transition. So what am I here to talk about? Well, I want to say a couple things I'm not here to talk about first. I'm not going to talk about how big IPv6 address space is. I think everyone's heard the comparisons to buckets of sand the size of the sun. They've heard about gazillions of addresses per person. We all know it's a big address space, and that's a benefit. We don't need to talk about it. I'm not going to talk about how efficient IPv6 is or all the performance enhancements. Yeah, they're there, and when we actually get it deployed, we can start leveraging those things. But that's not the real driving factor. Not going to talk about IPv6's history. Everyone knows it's been around for 15 years. Some of us have operational experience going back 8 years with IPv6 on our network. Not going to talk about NTT and how big we are. Not even going to talk about our backbone, even though it's really nice. So what I'm really here to talk about is scale, and scaling the internet and continuing to scale the internet so that we have this incredible platform that we've leveraged for the last 15 years into the foreseeable future. So what do I mean by scale? I mean 2.1 billion users as of March this year on the internet, and growing exponentially. So in still only 30.2% of the world's population. And as of June, the United Nations actually declared that internet access is a human right. So I think we can expect this trend to continue. So quick pop quiz. This is where I base the entire rest of my presentation on an unscientific survey done here. How many devices do you have with you today at the conference that are internet capable? So let me start. Does anyone have 4 or more? He gets a prize. How about 3? That's how many I have. 2? 1? 0. There's an Apple store up on 5th Avenue, and yeah, okay. Okay, so just, I think pretty much we can agree that the average was about 2, or median was about 2. Okay, now think about your home. How many internet access devices do you have in your home? I've got to start with a higher number here because I have about 10 in my house at least. So 10? 10 or more? All right. 7 or more? 3 or more? All right. Anyone only have 1? Or 0? Okay. So I think we can all agree that there are a huge, with 2.1 billion users, and granted, probably worldwide the average is lower than 2 mobile devices and 5 or 6 devices in their home. We can still agree that there are more devices that are out on the network today than there are addresses. So what does that mean? Oops. Actually, IPv6, IPv4 addresses are already gone, so how are we going to continue to look at this growth? So if you haven't seen this chart today or recently, IANA and APNIC both are out of addresses, and there's a projection from Greg Houston of Potoroo.net talking about when the projection for all the other RIRs to run out of addresses are. So luckily, in the US, we may have until 2013 before we're out of addresses, but the people in Asia are already out and having to move very rapidly to other solutions. So where does that leave us? As a common phrase, we're at a tipping point here where we can look at really 2 options: continued use of NAT or a whole-scale migration to IPv6. And I don't want to, the 2 are a little bit interrelated because NAT is in some ways a viable transition mechanism, and it's going to have to be supported. But the end goal really needs to be IPv6 for a couple of reasons. So there's nothing really wrong with NAT. If you only look at the way we run applications today and you do that kind of half-heartedly, really what NAT limits us to is the client-server model of communications, where large amounts of data and compute are stored in central data centers, which is the trend that we see today, and then people access that data. But it also introduces bottlenecks and those limitations. So the reality of carrier-grade NAT and large-scale NAT is it's a bottleneck. It's a traffic jam. It's a point in the network where we've tried to aggregate too much traffic flow through a single box. The other thing, as I mentioned, that this leads to is the architectural limitation that we have to rely on centralized data storage that's in this relatively finite area of global address space. What we lose is the ability to expand to a much more any-to-any sort of network service, which as we move forward in the future is going to be very important. So what about IPv6? The thing about IPv6 is it actually keeps the model that we've been building successfully for 15 years as the base architecture of the internet. In the Air Force, we had a saying, "Keep it simple, stupid," which was attributed to Kelly Johnson of the Lockheed Skunk Works, the creator of the U-2 and the SR-71. But other people have said it other ways, Einstein and Da Vinci as 2 examples, where in order to be able to really scale this network and to unleash the possibilities of the internet, we need to keep the solution as simple as possible. And as simple means that we can actually have any device on the network communicate directly with any other device on the network, rather than trying to centralize things into large aggregation centers. So when I was at the Juniper, let me make sure I get Network Innovation Leadership Summit a few weeks ago, Pradeep Sindhu and a futurist named Ray Kurzweil, sorry, we're talking about what leads to innovation, not just in the networking industry, but in all technology industries, whether it's biotechnology, whether it's macro or microbiology. And the point that they came up with was everything today is tied to the expansion of compute power. And it's more than Moore's law in terms of being able to improve silicon, it's the ability to improve silicon, it's the exponential growth of any-to-any networking, and the exponential growth of persistent storage. Those three things together are what drives innovation in our society today. So with IPv6, we get to continue this principle that the internet was founded on, where any device can communicate with any other device in the network. We get the high-speed any-to-any networking that people rely on today, and we enable a whole new rash of applications and services that we haven't even dreamed of yet that rely on this network of things or mesh of machines. So I think that's something that everyone needs to be very cognizant about, that IPv6 is an enabler of technology. It's not revolutionary. It's not something that is going to change things immediately, but without IPv6, we're going to stagnate from a technology perspective. So what can you do today? Back to the original discussion topic. The first thing we need to remember is that this problem is big enough as it is in terms of transition to IPv6. We can't compound the problem by trying to change business models. We can't compound the problem by trying to add additional functionality, new architectures, or anything like that. Really, the thing that we need to focus on is getting IPv6 deployed so that we can enable all those other technologies. So this isn't a problem where we have the luxury of taking time and making sure everything is new and exciting. We need to take the topologies we have today and leverage IPv6 to allow those to continue to grow. The other thing we need, as was mentioned in the last topic, I think Will was very eloquent in how he stated that IPv6, today it's just address space, and we need to get that content available in order to be able to continue this push towards IPv6. One of the things that I like to say is 2010 was the year that backbone providers really started taking IPv6 seriously across the board. We saw a huge uptick in the number of backbone networks that were deploying IPv6 and supporting it. 2011 is the year of content. With World IPv6 Day, we proved that IPv6 is ready for prime time and that content providers can safely start allowing IPv6 access to their content. Hopefully 2012 will be the year that we start seeing eyeball networks move forward with IPv6 so that we can actually start realizing this end-to-end IPv6 capability that we need. So, thank you. Sure, absolutely. If any questions or comments?
Got one. How do you reconcile any-to-any device communication with security on the network? Either even for an enterprise or even for a consumer?
I believe that you have that problem whether you're doing IPv6 or any other sort of communications from any sort of unsecured network. Really, the security needs to be enabled on the device. The device has to have the ability to secure itself without relying on external access. NAT is not a security device. NAT is a device to extend address space. Anytime that a connection isn't established from a machine, it's vulnerable. So I don't try to correlate the two.
I mean, because one of the advantages of NAT is that for devices that I want to keep access restricted from, so that it can only have outbound access, right? That it can only initiate access and can't act as a server, right? I can take advantage of NAT to intrinsically provide that level of security. Well,
what you're talking about is a firewall function, not a NAT function. A NAT, again, NAT is a network address translation device, and my point is that any time you initiate a connection from a machine, that machine is vulnerable to be exploited.
Yes, that is true. Okay, thank you.
Okay. I guess I went a little fast. Sometimes I forget to slow down and breathe.
I may have lost some of your note cards under the podium too. So Doug, obviously you're not a big fan of NAT, but most of the service providers I'm talking about are seeing carrier grade NAT as a necessary evil for the next few years. What's NTT's approach? Are you guys going to be doing carrier grade NAT, and what do you see as its lifespan?
I don't think that we'll be doing, as a backbone provider, I don't think that we'll be doing carrier grade NAT. I expect that some of our customers will be doing carrier grade NAT at the edges where they intersect our backbone network. But from a backbone perspective, our whole thrust is dual stack IPv4 and IPv6. So once it reaches us, we're not expecting to do any sort of natting or translation. But we're working with our customers to make sure that we can help them establish what the right technology is from a translation or natting technology.
Thank you. What can you tell us about NTT's policies towards peering, transparency? Do you pass QoS and multicast across your peering points? Do you carry them internally for the customers that happen to be on NTT Communications Internet services?
So this is from a QoS and multicast perspective. We do multicast peer with many of our peers. We don't do any sort of QoS service. This is kind of where I get back to IPv6. We can't compound the problem by trying to fix other problems on top of deploying IPv6. Those are valid, technology and discussions about how you can provide end-to-end QoS. But that's completely orthogonal to whether we do IPv6 or NAT or any other underlying technology.
Just a follow on then. Even if it is completely orthogonal, what do you do?
Right now, like I said, we don't actually have any sort of QoS exchange from our public IP network with other peers.
You carry them internally?
Yes.
So NTT has been at the forefront of IPv6 for many years, and as Japan is always at the forefront also in terms of mobile, cool applications, things like that. So what can you tell us of what's going on in Japan over the V6 network that NTT has in terms of interesting applications that are taking place, really taking advantage of IPv6? What kind of mobile, let's say mobile banking applications, anything that we should be knowing about that really takes advantage of V6 over the networks that are application oriented? Thank you.
I think the best example to use is NTT's next generation network for residential access, where it's actually a complete IPv6 closed network that's being used to deliver not just internet, but television and other sorts of value-added services on top of the NGN network. So it's using IPv6 as a transport technology and then gatewaying from that IPv6 to the internet for IPv6 as well.
And is this V6 native or is this dual stack? What are you guys doing over there?
It's V6 native.
Great. So what are the advantages that you've seen being V6?
I'm sorry? Yes, it is multicast also.
And so what are the advantage of being both V6 native as well as multicast that you're seeing versus what other carriers might be experiencing, or where you're experiencing in other locations on your network that are not V6 native? Can you tell us a little bit about that?
In terms of the residential network in Japan, I don't have the actual experience with what they've done there to be able to really compare it to other technologies that they've used. From the backbone perspective, as one of their backbone providers, we see the native IPv6 traffic hitting our backbone, every day in Japan now from it. Sorry, that's not really a good answer, but I don't have a better one.
I've got another question, does anybody? So I'm very curious what's going on over there. So what about the user experience? How are you selling this V6 native home connectivity to the consumer? And what has the consumer experience been with it thus far?
Well, from a consumer perspective, they don't really care what the underlying technology is. They want their integrated services. They want the ability to have things like interactive television services where that's being utilized for more than just broadcast. those sorts of technologies that providing IP-enabled, whether it's IPv4 or IPv6 television, are things that the consumers are very excited about. And then just the high-speed internet access as well. So it's been very well accepted. I think there's 9 million households in Japan now that are enabled on the fiber to the home next generation network.
I'll ask one further last question. And how about any best practices? Any best practices in the implementation of that network and the applications, how it's used, that you can share with us that we should be taking home with us?
I honestly don't have the best practices from their home network deployment, but we can actually get the right contacts for you if you contact me afterwards.